All right, so life goes on, and we have to talk a little bit about the assignments that you have to do in this subject. We had a group assignment that I have canceled and substituted by 2 additional assignments. The assignments will be presented in the material, in the PDF of our subject as the whole rest of the content. So if you go to your material, you'll see that I have already updated the individual assignment 1, and this will be a quick overview, a simple overview of this assignment. In assignment 1, you are faced with a production distribution problem from Chemical. So we are assuming that Chemical is a company that produces insecticides, and they have some distributors that have demands for these insecticides. So for example, VMART wants 8,000 liters of Chemi-Ant, the insecticide for ants, and so on. Chemical does not send the products directly to the distributors. It sends actually through some warehouses. So it has 4 warehouses and 3 blending plants. So it has 3 blending plants here. They produce, according to some capacity, insecticides, and they have to send these insecticides to one of the 4 warehouses, maybe to multiple ones, and from these warehouses the product goes to the distributors. So here we have our 3 plants, 4 warehouses, and 6 distributors. Your goal is to minimize the combined cost of production and distribution. So you have that you have the demands here, you have the capacity of the warehouses, the capacity of the plants, and you have the costs, the transportation costs between each one of the warehouses and each one of the distributors, and from each one of the plants and each one of the warehouses. So your goal is to find how much to produce in each of the plants, how much to send to each warehouse, and from each warehouse how much to send to the distributors. I want you, in question 1, to give me the minimal cost solution for this distribution production problem. And what I want as answer is that I want you to produce a model that will solve this problem, explain your model, and give me the solution. And for questions 2, 3, and 4, we have little modifications of this problem. For example, in question 2, now we need, or we know that we can lease additional capacities. If the plant is full, you can buy extra capacity. So you can buy for $38 capacity to produce 1 liter of these rather expensive chemicals. Then in question 3, I'm assuming that you cannot mix these chemicals, and each one of your warehouses has some kind of partition. So for example, your warehouse 1 is partitioned in 2 areas of capacity with 150,000 liters. Sorry, this should be 1,000 liters. So this should be 50,000 liters, 50,000 liters. I'm going to update the PDF. So the idea is now, if you want to use this area of the warehouse, you can only put one kind of chemical there. So what's now, does it change your cost? Does it change your optimal solution? That's your question 3. And in question 4, you are asked to design the optimal sizes of these areas, supposing that each warehouse can be partitioned in 4 different areas. And you can partition as you like, as long as each area has a capacity that is a multiple of 5,000 liters. You will submit this in Canvas in the assignments section. So I have put a link for you to to submit this. You should find these in the modules. And then if you go to assessment overview and you have the individual assignment, and here you can try to submit your assignment, and you'll be added to add a PDF file containing the report, the answers of the models and the explanations, and eventual code, the code that you used to produce the answers. I will put this assignment as an announcement, and if you have questions, please comment on the announcements link in Canvas.